I thought I'd just correct a few video I did. I was talking about to flick it to times 10. Well, I meant the other way around. I meant from times 10 to times 1. Times 1, yeah. So little things like that really bug me when I get them wrong, you know what I mean? I'll just flick the camera around. So, okay, when I start to make mistakes like that, when I start to, I suppose I can flick my camera or something, I don't know. So when I start to make mistakes like that, it's because I've been doing too much. I haven't gained, and yeah, I screw up a bit. I tend to make more mistakes when I'm tired and been doing too much, and I get things backwards and things like that. But so because we've got the 12 segment rotor assembly, it means that we can get a much higher frequency on the output for the revolutions. So I think it's 1000. I think I'm up to 1800 RPM or something. Was it? Yeah. We're almost at 2000 RPM with this optimizations I've been doing. So that's really good news. Because the more RPM and the less drag I can get, that means the less input current I'm using on the rotor. The old saying goes, a penny saved is a penny earned, or I suppose if you're in America, that's a cent saved is a cent earned. So it depends where you are, I suppose. But so anyway, I'm a bit stuck at the moment. I've been looking around for some wire because I've used all my wire up, and most of the wire that I wanted to recycle. Oh, I better go back to the camera. Sorry, I'm a mess right now. Most of the wire that I was looking to recycle is the thick stuff, and I don't want the thick stuff. I've got plenty of 30 SWG, but what I was looking for was something in the region of 32, 34, and I can't buy any till next Monday. So I mean, my transformer trucks that are around, they've got the thick wire on, so I can't recycle any of that. I don't want to do anyway. I might need them sometime. It's a lot of work doing them. But I did manage to find a spool with 32 SWG wire on it. So yeah, there's quite a bit on there. So what I'm doing is I'm printing another coil holder. Sorry about this thing that's stuck in the back. Oops, no, it's popped out now. It was just to keep this thing splayed out, because they clip in, they spring outwards when you put them in the rotor on the assembly, and I want them to spring outwards because it helps to clamp them in place. Because if they don't clamp themselves in position, they just fall straight in or out or whatever, you know what I mean. So I like a bit of springiness in them. Put that back in, it helps to push them out. So what I'm doing at the moment is printing another canopy. The reason I'm not going to use this canopy is because it's got the short coil wraps on there, and it's bonded onto the plastic now, so there's no way getting it out easy without cutting it all out, and that would make a mess. So I'm printing a new canopy at the moment with the bigger pegs on it, so I can get more wire on, so I can wind this wire onto the new canopy. And oh yeah, I worked out on something about overcoming some of the drag, and I printed this new segment. This is just one-off prototype. So we've got a bit of where's my little paintbrush? So I couldn't find the right piece of ferrite, because without cutting anymore, I didn't want to use anymore. So I just took a generic piece of ferrite in, which seemed to fit. It's a bit thin actually. It doesn't fit in the hole properly. There's a big hole in the middle. You can see light through the bottom there. But this was just to do a little test. I had a theory about, as the magnet is passing, this will help to, because what you do when you have got a magnetic field, say a south field, travelling through a piece of ferrite, what you have is basically, it's like a battery in series, right? You've basically got a battery in series. sort of thing. And what's happening as the magnet is passing this point, this axis, it actually pulls to this point pretty strongly. The magnet will pull there pretty strongly. Then when it passes, as it passes the magnet, I mean the ferrite, there's less drag at this point between these two, because what's happening is you've got a phase shift. The south field is going up there, and then as it crosses over this threshold point in between, the south is travelling up this piece of nanocrystalline, which is what I've stuck in that little slot there. There's about 4 layers of, was it 5, 6, I can't remember, 6 layers I think. I folded 3 pieces up, and so what happens is you end up, instead of south is going up there, and as it crosses over, south is travelling up there, so you've got south and south meeting each other at the top section, which creates repulsion, and the repulsion overcomes the drag, so it means that the magnet can leave more easily. And this is a thin piece of nanocrystalline, very thin, so because it's so thin there's less attraction anyway, so you have an effect. I don't know if I can show you with my magnets. Where have I put that magnet? I've stuck it somewhere. Ah, there it is. So if I get these little magnets, right, what we see, I don't know if I can demonstrate this at all, it might not work. Let me see. Right, you can see it flick. Right, if I stick the magnet there, you can see it jump across, right? Oops, I don't want it on its side. You can see how it jumps to that point. Now, on this side, it's a lot weaker. If I don't, this plastic's run out, so I can't really run it from a distance. So, if I try to put it at that point, look at that. It's staying on the edge. It's hardly. See that very limpy, very weak drag? It didn't really move. You see what I mean? That was very weak, but a big jump from over here, right? So I'm trying to demonstrate this. So from this point, we have a lot of pull, but right on the edge on this section here, we have very little pull. There's very little drag on there. I mean, look. I can barely pick this up. Barely. It's actually pushing down, look. You can see the repulsion effect. So look at this, how it rocks. See, it's pushing down. You see that? See? It's pushing instead of pulling. So my idea is to use this method to overcome the drag as the rotor magnet is passing. As it enters, it's going to pull into that point. As it slowly crosses that threshold, it will start to push. That will overcome some of the drag that we're having, the problem. So this is a new design I'm working on right now. So look at that. It's interesting how that is actually pushing. It pulls a little bit over here. Oh. It pulls a little bit here, but it pulls a lot when it gets further in. When we get to that point, it's really pulling quite strongly when you get right over the ferrite. But over here, you'll see it pushing up. It's actually pushing, rocking that thing down. So don't you think that's interesting? These are not magnets, but look, right, it's pulling, pushing. Look at that. That is interesting, isn't it? Because what's happening is you've got the field traveling through the magnet, through the field is traveling down there and down there, and the two fields are colliding at this intersection, creating a repulsion effect. So it actually rocks this thing, pushes it down, so we have less drag. Right, so this is pulling. As you can see, it just lifted the damn thing up, and we move across to this threshold point, and it's actually pushing. I ain't even touching the thing. Look. Oh, right. Oops. Watch this. Are you watching? Oops. I want it on its back so it's balanced. Right. Watch. Oh, stay over there. Try to get this on camera. Have I biased it something? Hang on. Let's go over it now. You see it lifts it up there. and when I get to this point, just here, oops, there, it's pushing down. You can seal it up. And it's not touching. Watch. So over here it's pulling as it's lifting it up a bit. When we get right over to this intersection, crossover point, and it starts to push right there. Pull, push, pull, push. If I take it away, the magnet's away, this thing tends to stick a bit, so I want something really flat because this table's not perfectly smooth. I haven't got anything really smooth to put it on. Pull in. Push in. You see the effect? So that will overcome that drag as we're leaving, because these segments are going to be rotating in this direction, right? So the magnet stators are below the ferrite, so these are moving in this direction, right? So the ferrite enters, then it's dragging on there, and it crosses over the intersection, and it starts to push away, so it doesn't actually create much drag. So this is my new design. I've got to do the other one. It's like a snake. It looks like a snake, doesn't it? The shape. But that's what I was working out, and I modelled it up, but I haven't done them all. This is just one segment. I've got 11.5 segments more to go. I mean, I've got to do that half, then another 11 segments. So yeah, and I'm going to take the ferrites out the other segments and put them all in here, because that's just a temporary piece I put in just to try it out. I had a theory and it seems to be valid. It seems to be. So anyway, what else was I was going to update you on something. I can't believe I've been talking for 13 minutes already. 13 minutes already, bloody hell. So I'm printing the canopy at the moment. Waiting for that to finish, and there was something else. I forget what I was going to do. What I was going to say. What? Oh yeah, the camera stand should be here on Wednesday, I think. I'm keeping an eye out for it. But otherwise, there's not much else happening. I mean, all I can really do at the moment is to sort these things out, which is a bit tedious. I'm using the scrap nanocrystalline material that's in my tub. Got quite a bit of scrap stuff in there which I can use for the snaky thing. But I don't know. I haven't even given this rotor system. I haven't even christened it. I haven't even given it a freaking name. The other device, obviously my other devices, these were called my bubbleators, you know. Kind of a funny name, I know, but because of the way I was actuating the flux, but it didn't seem to do a lot of good. But this hasn't actually got a name yet, and I have to think of a name for it. Maybe I should, because I call it segments, maybe I should call it the orange generator. No, I better not. I might step on some orange toes, if you know what I mean. Actually, I think, didn't Orange go out of business? Oh, I think they did. I can't remember now. I'm not sure. I haven't heard anything about it lately. But anyway, apples and oranges, whatever. I don't know what to call it. I haven't decided yet. I'm still working on a name. If you've got any ideas, tell me, because it might inspire me. Yeah, you might even get the honour of christening it. I don't know. Anyway, I'm going to go because, yeah, I had a really, God, last night I went to sleep and I was trying to catch up and sleep. I had such a weird dream. I realised when I was in the dream that it was a repetitive dream. It's the same frigging dream I've had before, and I'd forgotten I'd had it. Then I realised deja vu. It was a deja vu sort of situation where I had this piece of equipment. I can't remember exactly what it was. It was a tape deck or something, and it was broken, and I couldn't fix it. And it was driving me crazy. And it was, oh yeah, I was in this house and I went out somewhere. I came back and somebody'd stolen all my hi-fi equipment and all my electronic gear, and I was completely destitute. Yeah, it was a horrible dream, and I couldn't invent anymore, and I couldn't make anything anymore, and it was, yeah, that was the end of my life basically. And I woke up and I thought, thank God for that, it was a dream. I hate those sort of dreams. I haven't had a bad dream like that for a long time. Mind you, it's probably because of the medication I take normally, but yeah, it probably suppresses dreams, but I don't know. But anyway, last night I didn't take my medication, so I just went to sleep and I had this really wild dream. And yeah, there was this piece of equipment I was trying to fix and it didn't work, and that was still there, by the way. Everything else that worked had disappeared, and the thing that didn't work was still there. So yeah, it was a really depressing dream. I was left with garbage basically. So I don't know why I have dreams like that. I really don't. I mean, most people say, well, that's not a bad dream. Well, it depends on what your priorities are, what your interests are. I mean, if you're into electronics, I mean, your electronics are your life sort of thing, you know what I mean? Anyway, I'm going to go. Yeah. I'm still watching Let's Dig. I'm looking to see if Shangu's got any more videos, actually, because he had one the other day about the Westinghouse radios. I thought they were really interesting. It was really some good advice about soldering components and things. But you know, a lot of the stuff I make, a lot of the stuff I design, like the circuit board, I designed it in my PCB designer program, Design Spark, and modelled it and printed it. I had to design all these chokes and everything, which are basically opposing chokes. They cancel out noise on the line circuit. I've got one there and one there. I 3D printed the little covers that go on the toroids, because little green toroids in each one of these, and that's just a stand. It's not a toroid. But I 3D printed the toroids, and I wound two coils side by side on the toroid, opposing each other, so it cancels the noise out. And this all works great, you know. But when I built this, you know, what I usually do is I use tweezers to hold my component legs. I just get my I know that Shangu was talking about using pliers, but I just get my tweezers and I just grab the component leads and I hold them and I just bend them around my tweezers. That's what I normally do. But some components, you know, and he was talking about using hooks and that. I mean, yeah, it's a good idea to use a hook on your wire when you're joining two pieces of wire, especially when you're repairing equipment. But for long-term repairs. But most of the stuff I do is temporary, you know. A lot of this stuff I build is temporary, and I don't want to hook my wires when I solder it because I want to take them off at some point. So I do tend to just lay them on or solder them because I want to recover the things like these capacitors and things like that and use them again. So I do tend to just lay stuff on temporarily. I mean, it's alright for short-term testing and stuff like that and builds and things. Where if you started hooking your wires on, you wouldn't get them off, and then it'd be a pain, and you would have to cut your wires, and you wouldn't have wire left. So when you're recycling components and using it over and over and over again, you tend to make temporary solder joints, and that's what I tend to do. Make temporary solder joints and things like that. But when it comes to a circuit board, I like to make it really neat and proper and everything else, and I even 3D printed this little tray for the board to sit on so that the board wouldn't sit on anything and short out on the table, so the trays to protect it from shorting. And it's actually got little vents underneath. I don't know if I showed you that in the previous videos, but just move that out of the way. Just get that capacitor out of the way. The actual tray has got little holes underneath to let the air in. So as you can see the bottom of the circuit board down there. So I've got a silica gel packet in there as well to keep moisture off the circuit board, so it doesn't get damp and affect the frequency. It helps to stabilise things a bit. So anyway, I'm going to go. I'm waffling too much. Right, bye for now.